All right, today we're going to be going over the section 12.5, which is the last section of chapter 12 that we're going to cover. So 12.5 covers problems with normal distribution. It's really going to focus on two things: z-scores, which we talked about last time, and then percentiles. Percentiles is the new thing we're going to be talking about. All right, so with percentiles, if we zoom in just a little bit here, okay. Percentiles, all right, is the percentage of people, things, whatever, that fall below a certain score. So in this case, we've got some data, we've got a z-score that correlates to a percentile. So if we specifically look at this z-score here of 0, it correlates to this 50th percentile. What that means is 50% of the data falls below this particular z-score, and different z-scores correlate to different percentiles. So in this case, a z-score of 1.5 has a percentile of 93.32. What that means is 93.32% of the data falls below this particular score. So what we're going to do is we're going to go into the study plan and we're going to look at some specific problems. I'm going to show you how this works. All right, so we're in My Math Lab here at 12.5. We're in the study plan. So My Math Lab, I'm here in the study plan. Remember, you'll go to the assignments, but anyway, 12.5, if we just start with question number 1, it's going to ask us, well, first off, you're going to see a data table. Okay, and again, this is correlating z-scores and percentiles. So this particular z-score correlates to this percentile. So they're going to ask us some questions. We zoom in just a little bit. Okay, use the table below to find the percentage of data items in a normal distribution that lie below and above a certain z-score. So specifically, we're looking at a z-score of 2.5, which if you look on your chart, the z-score of 2.5 correlates to 99.38 percentile. So again, a percentile is the percentage of people that fall below that data point. So question A, what is the percentage of data items that lie below a z-score of 2.5? That is simply that percentage there, that 99.38%. Good job. Okay. Now, if it's asking for the percentage of data items that lie above that z-score, so again, z-score of 2.5, 99.38 percentile. That is, again, the amount of data that falls below. If we want to find the amount of data that goes above, remember, 100% represents the total. So if we subtract those numbers, so 100 minus 99.38, we get 0.62 or 0.62%. So that would be the percent of data that would be above that mark. So 0.62. And if we go to the next question, it's going to give us similar data, but it's going to change the context up just a little bit. So if we zoom back out so we can see the whole thing here. Okay. Again, use the table below to find the percentage of data items that fall below a z-score of 1.3. So if we look at our chart, we'll find the correct z-score, so this 1.3. And that correlates to a percentile of 90.32. And again, the percentile is the percentage of items that fall below that. So if we're trying to find the percent below this z-score, that would be the 90.32%. So again, if they ask us for the percent above, then we take our 100% total minus our percent below. So 100 minus 90.32 is 9.68. So that 9.68% represents the percentage above that specific data entry. I'm going to pause the video and then we'll go to a different type of question. All right, I moved ahead. We're at question number 5 now, and this just gives us a different type of question. Very similar, but just a little different. Instead of talking about the percentage of data below or above a specific number, we're looking for the percentage of data between two numbers. So again, it gives us two specific z-scores. So a z-score of 0.4 and a z-score of 2.2. So it gives us two very specific scores that we're looking at, and we want the percentage of items between those. Well, at 2.2, 98.61% of the data falls below that, and then 65.54% falls below a z-score of 0.4. So if we want to find the amount of data between, or the difference, we just simply subtract those percentages. So if we take that 98.61 minus that 65.54%, that gives us a difference of 33.07%. So that would be the percentage of data that would fall between those two values. So 33.07%. That's what would fall between those two z-scores. Simply subtract those percentiles. And again, they can give you a similar question where they want you to do the same thing. So z-score of 1.3, z-score of 2.7. They want to find the percentage between those two values. So you would take that 99.65% and we would subtract that 90.32%. Or a difference of 9.33%. So that would be the amount or the percentage of data between those values. All right, here's another type of question, very similar with an extra step. So again, they gave us a data with z-scores and percentiles, and then they're asking us a question. So what is the percentage of people with a reading below of 136? Now, wait a minute, they didn't give us a z-score. So they gave us a specific data entry, but all the data is based off of z-score. So we're gonna have to be able to find that z-score. You'll remember from last time, a z-score is found by taking your specific data item, and then we need to subtract the mean of the data, and then we divide that by our standard deviation. So if we take our data item of 136 and we subtract the mean of 127, that gives us 9. Divide by the standard deviation of 19, and we get about 0.47368 for a z-score. Now, also pay attention, they want us to round our z-score to the nearest 10th. So if we look at 0.473 yada yada yada, this number rounds our 0.4 to about a 0.5 z-score. So a test score of 136 correlates to a z-score of 0.5. So our z-score of 0.5 is here. That correlates to a 69.15 percentile. So again, if they want the percentage of people below that 136, we needed to find our z-score, so we could find that on the chart and recognize that 69.15% of the data falls below that specific score, so 69.15%. Okay, and this should take us to a similar question All right, and again, they gave us some information. We're looking for the percentage of people with readings above a score of 138. So in this case, there is no data table for us to see right here, but if we click on this icon, that should bring up our data. So there we go. And again, it's going to be all based off of z-scores. So we again are going to have to find or determine the z-score before we can continue with anything. So for a test score of 138, we need to figure out what that z-score would be. So again, we take our data item minus our mean and divide by our standard deviation. So our data item was 138. Our mean was 129. So if we take 138 minus 129, we get 9. And then if we divide by that standard deviation of 13, we get 9/13, or about 0.692. And again, round our z-score to the nearest tenth as needed. So that 0.692 is approximately 0.7. So I am going to bring this over here to the side so I don't forget that number. So we need a z-score of 0.7. So then if I pull up the data, we can find that particular z-score. So a z-score of 0.7 is right here. And again, that correlates to a percentile of 75.80. And again, percentile is that percentage of items that would be below. That's going to be important because, again, they didn't specifically ask for below in this particular problem. Okay, pay attention. The percentage of people with readings above that 138. So if 75.8 is the percent below, then remember we need to subtract from our 100% total. So 100 minus 75.80 gives us 24.2%. That would be above. So 75.8% scored below this number. So 24.2% scores above. So pay attention to whether it's asking for above or below. Remember the first couple of problems it wanted both. Then a couple of problems later it wanted between. The last one wanted below. This one's asking for above. So pay close attention. Don't get caught by making a silly mistake. All right, the final thing I want to draw your attention to is they can give you percentiles for specific data items and not correlate it to a z-score. All right, so for this particular data, we have the ages of licensed drivers in a country corresponding to the percentile. So again, that's the percentage of people below that age. So if we want to find the percentage of drivers who are younger than 35, then again, we look at our data item of 35, which gives us a percentile of 39. What that means is 39% of our licensed drivers are below 35. So specifically, the percentage of drivers younger than 35 would be that 39%. If they ask us a similar question, okay, we want to know the percentage of drivers who are at least 55. So again, look at 55. That gives us a percentile of 79. So 79% of the drivers are below the age of 55. If we wanted the percentage of drivers who are at least or above, okay, then again, we would need to subtract from 100. 100% represents the total. If 79% of the drivers are below 55, we subtract that 79, that gives us 21% of our drivers that would be above or at least 55. So that concludes what we're going to talk about with 12.5. Remember, this is the last section of chapter 12. Next time we will be doing a review for chapter 12, and then we will test whenever I get back from quarantine.